Shall we start the presentation?
Sure. Yeah, please start.
All right, so we're currently working on Anchor protocol. I think it's better to turn our camera on. One moment. All right, here we go. So we're currently working on Anchor protocol, and in this presentation, we'll be talking about the specifications on our side, the requirements of uh, cross-chain communication wormhole that you're currently building. And before we start with the requirements, I think it's first beneficial to give like a brief introduction of what Anchor Protocol is to find out the rationale behind our requirements. So to start off, if you look at current like DeFi money markets, the architecture is quite simple. So Alice is the borrower, Bob is the lender. Alice deposits collateral to a smart contract and lends out some kind of loan, which Alice has to pay interest to Bob in order for that loan. And the problem here is that the demand for loans is highly reliant on market fluctuations. So the reason that people take out loans is because they want to speculate on token price. So the demand for loans also fluctuate with the market, and that also causes the interest rate that Bob receives to fluctuate with the market as well. So we thought this was a problem for mass adoption in DeFi to happen. So our difference was to introduce the concept of liquid staking into money markets. So instead of just receiving any tokens as collateral, we receive what we call B assets, a liquid staking token or staking derivatives. And if you hold on to a B asset, you receive the staking rewards of the underlying staking position. So we use the staking rewards from B assets to subsidize the interest rate of Bob so that we could give out high and stable APRs during periods of high market volatility. So the landscape we envision for Anchor is we don't want Anchor to be built up all by Terra. We want it to be a collaborative effort across different proof of stake chains such as Solana, Cosmos, Polkadot, and Algorand. And we expect those chains to implement their own contracts that have liquid staking enabled and have their own B assets, BSOL, BAtom, BDOT, and BAlgo implemented on top of them. So as for the bridge, we need a method to transfer those B assets from the origin chain to the Terra chain where the Anchor smart contract resides. And we figured out it would be best if you could have like a standard specification on the interface of that bridge and also for B assets. And we named that Speculo. So Speculo is basically a BS and bridge specification for Anchor protocol. And what the bridge specification in Speculo does is that it allows a standard interface between different chains so that anyone could join the Anchor ecosystem when they fit the requirements of the bridge specifications. So for the requirements of Speculo Bridge, first of all, we need bidirectional token transfers as we need to transfer B assets from the origin chain to the Terra chain. And we need it to be signature level secure. We need a high level of security. And additionally, we need arbitrary message transmission to be enabled. And this is just to enable reward claims from the Terra chain to the origin chain. So we need to able to request the transfer of staking rewards and perform the actual transfer of staking rewards. And yeah, to go a bit deeper, for that we need two-way token transfers enabled and a bit of arbitrary message transmission, which which its purpose is to enable remote reward claims. And starting off from the technical implementation side, I would let SH jump in from here. So yeah.
Yeah. Hi everyone. This is SH Daniel from Carol. So the architecture for this particular bridge should satisfy three properties. So the first one is that data serialization and deserialization functionality should be processed within the underlying bridging protocol, which means that the bridge specification that we're defining should not be dependent on the underlying data transfer protocol or interchain protocols. And the second one is that the bridge spec only defines messages being transferred on the upper JSON layer. So as I mentioned before, the message themselves should not be affected by the implementation of the bridge itself. And the final one is that Anchor only requires reward withdrawal functionality accumulated on a remote chain where B assets are first issued. So for token transfers, we could resort to a much simpler solution, but because of this unique property where we need to issue commands to a remote chain to withdraw staking rewards, we need generate messaging that are consensus level complaint. And we define 4 major message types: init withdrawal request, init withdrawal response, finish withdrawal request, and finish withdrawal response. And it's really simple. It's just JSON RPC type of message that I won't go through very deeper. But it's basically RPC complaint. And anyone can build arbitrary message, and anyone can build messages that are Anchor complaints based on these simple standards that allow the Anchor system to withdraw rewards from a third-party BSN implementation that are on a remote chain such as Polkadot. So for integration and requirements, first of all, for Anchor, the bridge requires 2 large functionalities. So first one is that we need bidirectional token transfer to and from the Polkadot mainnet. And second, we need to be able to transfer reward. We need reward claim transactions from the Anchor system to the Polkadot mainnet. And thus, this will require direct integration with the Polkadot mainnet. And as described with the specification of Wormhole, this Polkadot integration is not included with the phase 2 roadmap of Substrate IBC. And as BMAT asset minting should be done on a smart contract enabled parachain, Cumulus and XCMP is an absolute requirement for us. But there is another option, and that is to mint B-dots on Terra's Cosm and WASM engine instead of a parachain. And in this case, staking message relay should be done manually on each chain. And secondly, there should be a mechanism where staking events on Polkadot can be processed independently and propagate properly to the Terra Cosm WASM engine. That's it for us. Thank you for listening.
Questions for the Terra team?
Just that maybe you could add the link to those slides to our notes document. I feel like this is a great reference.
Sure.
How should we do that? I just send the file to.
Yeah, not sure what format it's in, but you can. I mean, if you send it to me, then I can link it, or you can. I mean, we have a HackMD, so ideally there'd be a link posted there, and I'll add the HackMD link to this chat.
Unfortunately, it's a PDF file, so I'm not sure how to share this to you guys.
I guess
well,
I guess just email it to Sam and I, and we'll figure it out.
Yeah, we'll figure it out.
Gotcha.
So
just one question, sorry.
Yeah.
Ryan, that last point, number 3 there, you're talking about mint B-dots on Cosm WASM engine. Can you explain that again? What do you mean to mint B-dots on the Terra side?
Oh, so uh, so as an example, so some proof of stake blockchains do not have smart contract functionalities enabled within them, or access to the staking module. Both are required in order to mint B assets. But if those options are not available, we could instead create a contract on the Terra blockchain that remotely controls the staking, unstaking, and minting of and burning of B assets. So this is the mechanism that that number 3 describes.
Okay, yeah, makes sense. Okay, thanks.
So, I mean, could you go back to this initiate withdraw request and that slide? Which lists all the transactions.
This one?
Yeah. So the thing I'm quite curious about is, like this flow, initiate withdraw request and finish withdraw request. When I read of it, my initial impression was this makes total sense when we are thinking of a Cosmos SDK chain. And from the Terra chain, you are sort of sending these requests to a Cosmos SDK chain, reward withdrawal happens and then comes back. But in Substrate, there are sort of highly automated ways of doing withdrawal requests. Because what you can do in Substrate is, first of all, the validators you nominate, I think they are able to do withdrawals for all the delegators and restake them. Now, if the validators don't, then your particular controller, so in Substrate, there's a distinction between the stash key and the controller key. So in this interaction, if Substrate is interpreting part of your messages as having a controller key, then essentially that controller key can withdraw rewards, which means like if you put the controller key on some kind of off-chain process, then the reward withdrawal can be entirely automated without giving custody to the off-chain process. And also in Substrate, what the third possibility that exists is you can route rewards onto a smart contract automatically. That kind of thing is also possible. So the thing I'm wondering about is, have you actually looked at how like the reward mechanism in Substrate works, and does your proposal actually consider all the capabilities you have in Substrate which may not necessarily be available in Cosmos SDK?
Yeah, so these properties are common for all chains that we support. Because each and every chain has different mechanisms for claiming rewards and processing staking rewards and stuff like that, we need to come up with a very simplified set of requirements that can cover everything. And so we did take a look at how Substrate processes staking rewards internally. But as we mentioned, this is not Substrate specific. This is something that should be applied to every single proof of stake chain that we are trying to support. So that's why this was simplified in this way.
Right. My second question is like, how do you imagine the nominations process working? I guess like a more basic question is, do you imagine these B assets to be minted by some other protocol which is developed by some other team? The B dots. Do you imagine that this minting of B dots will be done by some other team and Terra just consumes those B dots? Or does Terra want to actively develop a protocol to mint B dots?
It's actually closer to the former. As an extension to Speculo, not just the bridge, but we also specify a standard interface for staking derivatives that will go as collateral in Anchor. So we do require a bit of modifications to existing other staking derivative protocols. But once we get once they fit our standard interface, and we are hoping other development teams could jump on this to share their efforts. Yeah, so we're trying to decentralize as much as possible, and we're not hoping to develop every BSS contracts by ourselves, but instead collaborate with other development teams as well.
I mean, if some other team is developing the B asset protocol, I am actually not sure why you need rewards withdrawal functionality from Terra to Polkadot in the first place. Wouldn't the team that is developing the B dots figure out how to withdraw rewards and make sure it accrues to the value of the B dots by themselves?
Well, we need a common interface that all of these different implementations should adhere to be compatible with the Anchor money market.
So, I guess this is going a bit off topic, but so as for the specular B assets specifications, one of the requirements of B assets is to have a one-to-one conversion peg between B assets and the underlying assets. So we can't currently we can't consider staking derivatives that have a constantly rising value, like for example, like delegation vouchers. Those are currently not in consideration. So we need to ensure both a one-to-one peg and the being able to claim rewards. I don't see any other method here. Oh yeah, by the way, I sent the presentation to your email, Behan. All right, great. Okay, any other questions?
So I guess like what I'm curious about is then it seems like if you go to the other slide that lists the various requirements, token transfers, signature level security, that particular slide.
This one?
Yeah. Could you kind of explain what signature level security and arbitrary message transmission is?
Signature level security means that that the Anchor smart contracts needs to be able to verify the signatures that has been made on the Polkadot chain. And arbitrary message transmission is simply a requirement to enable remote reward claims, because we would have to because we would also require the ability to execute arbitrary transactions, not just token transfers, on a remote chain. In this case, the Polkadot mainnet.
So if we have signature level security, that means relayers cannot forge signatures and cause fake transactions on the destination chain. Because if that happens, then the money market could break.
So signature level security is just that you don't want to trust the relayers, which is a default assumption of IBC anyway. And
Yep.
arbitrary message transmission is, okay. So, I mean, maybe this is where like somebody like Chris goes, or somebody might be helpful who really knows the IBC protocol. But my sense is that when you need bidirectional token transfers, you need unordered channels in IBC. So, yeah, messages can be sent over a channel, and there are no ordering guarantees of the messages, but and when you require rewards claims, at that time you actually need ordered channels, because reward claims have the nature that they must be processed in a certain sequence, right? So if you're issuing reward claim transactions in some way every X number of blocks, then one needs to happen before the other. And so that is sort of an ordered IBC channel. And in a bidirectional token transfer, you need an unordered IBC channel. So your basic requirements from the bridge are both ordered channels and unordered channels. And if those exist, your requirements are kind of satisfied.
Yeah, sorry, just to jump in from the IBC side, I think both the requirements are fulfilled. Like the signature verification and the arbitrary message passing, or message is just a different module in IBC.
Yep, I agree. It's not clear to me that you would need order channels for reward claims because the individual messages to claim rewards for different users should be causally independent. If you want some, I guess it depends on how you process them, but if you're processing rewards in a way similar to, say, how the Cosmos proof of stake system handles user rewards, where the rewards are calculated when they're withdrawn, you don't need to order things. If you end up with things out of order, it may be annoying, but it won't change the correctness. And if you don't need to order messages, use an unordered channel. You definitely don't want to impose an ordering requirement unless it is strictly necessary.
Okay, so what we could do is we could build the Anchor architecture in an asynchronous, so that it works in a asynchronous fashion. So in that case, I don't think order channels would be a requirement here.
Right.
I mean, it sounds like one thing you probably want to do with reward claims is automate the message sending. So every few blocks, you want to send a reward claim request. That works just fine in IBC. You just need to have some, and the Cosmos SDK, it would be an end blocker or some piece of module level code which runs periodically and sends messages to claim rewards or what have you.
Yes, we are currently developing that piece of logic.
Actually, that won't be done by the core blockchain code itself, but since we're trying to put a Cosmos contract on top of the Terra chain and have like a, I don't know, a server running that automatically does the reward claims.
Cool. Any other questions? Okay, if not, we can thank you, Ryan. Thank you, SH, and we can move on to C dot then.
Thank you.
Hi everyone. So can you hear me?
Yeah.
Okay. Let me share the screen. So we see that as you know, implement the IBC on Substrate, and so before we go to some details, I just have a brief.
Man, I need to be careful about what ASCII art I put in the spec document if it gets copied into PowerPoint presentations.
I see. I mean, I just want to mention that this is just copied from the spec.
Yeah, so it's my fault that it looks terrible, not yours.
Oh.
That's all right.
Yes.
I hope it was helpful.
So this is just to for these that are not that familiar to IBC, to give you some basic backgrounds, and like first, like IBC it's a standard and the basic is to do interchain communication between two chain, and like any other, I think like most of the cross chain like implementation or stack, the essentials are just you have a client. I mean this is the light client approach, and you have client on the counterpart of the chain, and the light client can verify another chain's consensus, and they're the relayer to relay messages, and here in IBC it's called packet, and like if you see this figure, I mean this diagram, you have like blockchain A, blockchain B, and state machine of each blockchain. And like if a module wants to send some IBC packet, you can use the IBC module, and then the relayer will relay it to another chain. This is too simplified, and this is a bit more detailed. And because the original one is too large, and I just cut the half, and the other half is just a symmetry. So like if you have there are some terms here, and like a handler, packet, channel, connection, client. Like consensus, relayer, and module, I think everyone know what's that about. And like here is the process, like from if one module wants to send a IBC packet, the process from the module through handler, packet, channel, connection, client, consensus, relayer, and then to ledger B, and then the opposite route. And here actually client is used to synchronize the consensus related, like especially the header, and connection is to confirm that the two chain is tracing each other's head, and channel is a kind a module to module channel to can also track the packet, the sequence, and packet is just the message. And also handler is like doing the inner module. Handler is something like connect the inner module to the IBC module. Actually, there's a routing module. Let's talk about later. This is the step, and it just from chain A, you go to first the application module will send some try to send some IBC interchain message, and the handler will go through packet and the channel, connection, client, consent. Basically, it's just the diagram here. And each of these is defined in some ICS or several ICS. And so now just talk about some details of our implementation, and what have done, and later there will be a summary. And here I just picked some of them. First, like on-chain client basis, and grandpa client and port, and show the demo. First is about on-chain client. It's actually it's ICS 02, and here there are some handshakes related things done, like connection, channel verification, and also packet verification and consensus verification. This is a kind of the backbone for an abstract client, and the backbone for the implementation. And here we implemented a grandpa client. It's ICS 10, and it's similar. It's not optimized, and the block header is actually submit and trace one after another. And here we are using Parity's grandpa phonetic crate, and it's called inside from the WASM. And about port, actually a port is set something that permits a module to use IBC and send IBC packet. And our implementation use the source authentication approach. Like according to the spec, is that each module has UUID, and in Substrate specifically, it's not UUID, but there's an index, module index in Substrate, and we use that to identify each module. And now I will show the demo, and actually the demo speaks more clear, and the demo actually in this GitHub repository, and it demonstrates the create the client between two Substrate chain, and establish connection and channels, and then message the packet be relayed by the relay process, and the other chain will receive the message. So I will show the demo. So as I said, this demo is located in that GitHub, and there are 3 submodules. And the core is no template. And there's IBC palette and some glue code. Actually, the Substrate sub-xt is an RPC client for Substrate. And this is just all the files. And now we start 2 chains. And it's a seeding blocks, both of them. And then we will create a client on the other side, like both chain will create it's a grandpa client on the another chain. And we need to enable a port. It's like a firewall to enable for later use, like open the firewall. Then we start the relayer process. And the relayer's message is configured here. Like we have one message from appear one to another chain and vice versa, the reverse direction. And now the header is synchronized through the relayer. And then we need to create a connection between these 2 clients. Then it will go through the init, try open, and open it's like a handshake. You see here is init from IPA. and then try open from Flaminia. And then finally open on both sides. The channel is established. Now it's established. Then we need to create a channel. And the process here looks similar to the connection. We try to open it on both sides. And then it will go from init to try open and then open. And now the channel is open. And now we can send a message, cross-chain message. And we send a byte of 1, 2, 3, 4 byte error. And then we can see the packet is received. That's all for this demo, and then that's all for the demo, and I will then talk about what we are going to do or what hasn't been done yet. First, we need to separate handler and the routing module. Actually, handler, currently there's a handler, and actually handler are these related to connect to the inner module of the logic, and routing module are these that related to or close to the relayer. And currently all of these things are implemented as a whole, and later we need to refactor the code and separate these two as the ICS, the standard, and then we may have more client support, like we may integrate Chorus One's Tendermint client, or there's another two because we don't have a Tendermint client yet, and then or we may implement another two ICS, is a loopback client or solo machine client. But these three is like maybe we will first pick up one of them. And another thing is currently the packet, because comparing to Golang, like callback, the function registration is much more difficult in Rust. So currently, as you just seen in the demo, we actually the packet is sent to the IBC module, but not directly to the logical module. I mean the application module. So we need to enable the packet to reach to the application module. And next is to use protobuf for serialization and deserialization. Currently, we are using Parity scale. This is essential for like if Cosmos SDK chain want to talk to Substrate SDK chain, then they have to use the same serialization, deserialization method. And so that's the protobuf. And also, I need to mention that all the misbehavior and acknowledgement and error handling is not done yet. So we need to add that, and also to add more tests. And to summarize, I just listed all the ICS and what's the current status of our Substrate IBC implementation. And like this is meta, so no need to meta spec, so no need to implement. And these two, the client connection channel packet port is implemented. Here implemented all means misbehavior, acknowledgement, and error handling not done. And here is the three clients that we may choose one or perhaps tendermint client to implement or integrate. And the grandpa is the grandpa client is just as I said, it's implement as the draft, but maybe the draft need to be improved because currently the header is just submitted one by one. And for the relayer algorithm, we just have a working implementation for our IBC demo, but it's not generic. I mean, it's not general. So we wonder if there's a kind of general implementation for this, but we just left here, so it's kind of not fully implemented. And for the 20 and 27, these are two IBC apps, so it's not our scope currently. And then for 23, it's implemented, and host requirement, it's implemented, but the original host requirement needs to have a path stream that to describe a path like for the storage place, but in Substrate, because there's no string, I mean there's kind of no string, and so we are just use a struct instead of the string. And for the 25 and 26, the handler and the routing, these two, as I said, they are implemented as a whole, but we need to do further refactor to separate them according to follow the spec. Yeah, that's all. Thank you.
Thank you. Great demo. From the IG side, we'd be super happy to work on cross implementation tests once you guys have protobuf implemented. It would be really fantastic if we could get the two implementations talking to each other. On the question of relayer standardization, so there are sort of currently two relayers under the ICF funding purview, at least that I'm aware of. One in Go, which G is working on, and Akash may also do some work on, and one in Rust, which Formal is working on. There is not yet a standardized API. I mean, ICS 18 is standardized as to the logic that relayers should be employing, but there isn't a standardized API for relayers to talk to blockchains. And that might be useful to develop. because ideally a relayer should be able to work with both Substrate and Cosmos SDK and future other implementations of IBC in other languages through a standard API.
Yeah, I think this is necessary, and perhaps we are not going to go deeper to the currently, because we have other things to do. I'm not going to go deeper in the layer things, but I think we may I think like if we do the Cosmos and Cosmos SDK and the Substrate the integration, then there will be some needs to at least have a working relayer for this. So at that time, we may have to consider this issue, and also to do something and to refine the API, I think.
Mm-hmm, mm-hmm.
So, so what's the plan from here on? So you've mentioned that the next steps you've indicated, and do you have any particular use case that you want to take into production for either substrate or substrate Cosmos bridge?
For application, we are not currently we're not considering to build some specific application. We just because there are as this table summarize, there's still some parts not implemented. So like these things. And currently we focus on implement the spec itself, and only after these things we may consider about these things, but currently we focus on implementing the spec, like to fully follow the spec. Like this kind of separate the handler and the routing module. This is if you want to have something just functioning, then you don't need to do this. But to follow the spec, you need to do these things. So still some work here. And about another thing is about the integration between like Cosmos SDK chain and the core and the substrate chain, and I mean, I think this is one of the purpose we are here at the working group. So maybe yeah, it depends on how maybe later or later work later meetings, and we may have a plan to push it further. I'm not sure, but we are willing to cooperate and have that integration. So if that's if after discussion that's our common aim in the near future, and we should also do that. But not, we don't have our own application yet, and it's not planned.
I have one question that just kind of sprung up for anyone at Web3 or Parity. Is there a story for communication between Polkadot and Kusama, for instance?
There will be. So yeah, you should be doing. I don't know if we have any Parity people here. There's certainly plans for a substrate bridge to be deployed in between Polkadot and Kusama. and it probably won't use IBC.
Do you aim for it to be semantically different in particular ways? I'm just curious.
The answer to that is probably not. It probably could use IBC. There are certain extensions which would be different.
Uh-huh.
But as far as I know, the Parity's current implementation, yeah, doesn't look all that like IBC.
Mm-hmm, mm-hmm. Are there features or additions that if IBC were to add, it would be usable for this purpose? Or
so that's a good question. I don't know. Like everything else, we'll see where it goes. Though, you know, we had some discussions about sort of basically challenging consensus of one chain on the other.
Interesting. So you
but
want
we're a
some
long way
kind
from
of
doing
fallback,
anything like that. So no, yeah, we're a long way from doing anything like that. So who knows? Probably no. There isn't a good reason why we're not using IBC or are using IBC, and we'll see how this thing evolves.
Cool. Well, just in case there do happen to be changes that we can make to IBC that would make it possible to use this purpose,
I think we'll, people will build these things and then we'll discover what it is we actually need.
Sure.
That's the way it works, right? Yeah.
Any other questions for CDOT? Cool. Then another topic was added to the agenda, which is consider staggered time zone. May I know who added the question, and could you explain what is meant here? Yeah.
I'm not totally sure who added it, but I did have a conversation with Zaki yesterday, and he was very interested in attending this meeting, but is also in California, so it's prohibitive for him. I'm not totally sure what the best solution is, but yeah, this seems to be working for the time being. If we have quite a few people in California that kind of want to actively contribute to these discussions specifically and aren't served by, you know, recordings or notes, then maybe we'd want to consider another arrangement. But people should voice their opinions if that's the case.
Yeah, I mean, this time slot was picked because we wanted to include China and Korea, Europe and USCT, and it was hard to put the Pacific time in. But yeah, if there's a different opinion for a time slot, happy to hear that.
Yeah, I mean, and this also wasn't meant to change the original plan of this one, but just thinking about a way to say, if we know that there's going to be somebody always left out, to maybe stagger it or something like that. So it's a different group that would maybe not be able to attend different ones or something. Maybe it's not necessarily this point, but I just wanted to sort of float it as a potential option for maybe solving that problem that we kind of have.
Well, we already have two IBC calls, right? There's this, and then there's the one which is later today, which is staggered so that it's more friendly to West Coast and less friendly to Asia. We're never going to get everyone in the same call. There are just too many time zones. But if there's specific things we could relay, I guess I'm just trying to understand better what you're suggesting that we aren't already doing or couldn't already do.
Maybe actually with the other IBC call, the problem's actually moot point.
Maybe now that we have to, we can do a more intentional job. It's mostly on Meher and I, but to relay information between them and ensure that if there are active discussions going on, that, you know, not everyone can attend because they can only attend one of the calls, that we relay results. I'm happy to do that in both directions, really. And Mahara, usually you also join both calls. So.
Yeah.
Is there a shared channel where we're all connected on either Discord or Telegram? Because we could relay information to our friends on the West Coast that way.
Sure.
They can respond to what's shared here.
Most people in at least the later call are in the IG IBC Slack channel, but I'm also happy to join other channels as people prefer.
I think there was an initial Telegram group that was just for kind of quick coordination. I don't think it has everyone in there. If there's a preferred channel that people have, then
can we use the shared IBC on Slack? Shared IBC is what I would suggest.
Yeah, I would prefer that. Yeah. I can invite anyone who doesn't have it. Just email me.
I'm certainly not on it.
Okay, well, we'll do some work on our end to figure out the best channel for that. I can take that on.
Yeah. Maybe a quick question. So, how do we want the next calls to be structured? Is it better to keep it open, or should I actually try to get, for example, there are other teams. So there's Parity that's building a bridge. There's Snowfork that's building a bridge, and there's Interlay that's not exactly a bridge, but it's a way to transfer Bitcoin over to Substrate. Do we want to hear from these teams, and do these teams want to present, or do we want to keep it open?
I would really appreciate, and this is just a request, which of course can be declined, but I would love to learn more about Informal's planned architecture for their IBC REST implementation, and potentially what could be shared or mutually adopted by some of the different REST implementations.
Yeah.
I think we'll be happy to present that in September, if that gives you a timeline.
Mm-hmm. Cool.
Yeah.
Any other? Yeah.
I've found the. I think Terry's presentation was excellent. It's really good to hear how people are thinking about this from a use case perspective, and I think it might be good to get one or two more on each side, on the Polkadot or Substrate side, and on the Cosmos SDK side. I feel like just some of the questions that came up today around channel ordering and kind of various questions around staking, sequencing are very valuable to tease out. So those are only going to kind of come up through specific investigations of those use cases.
Right.
Yeah, in band chain and Substrate will work. So yeah, next week we can potentially pull up some slides, and just it's not going to be long, but yeah, it should be useful.
Okay, so next week we hear from Band on what their kind of requirements and plans are.
Yeah.
And for Informal, we have some session in September, maybe early September or something like that. So yeah, 3 or 4
Yeah,
weeks.
that sounds good. Yeah, that sounds good.
Okay. And if anyone else wants to present something else that's related to topic, just drop me an email and I'm happy to hear. Cool. Then we catch up next time. Thank you everyone for attending.
Thank you.
Thanks all.
Bye-bye.